In order for Java 8 to introduce functional programming to the platform, it's added some new language features. The majority of those features exist to either allow you to code in a functional way, or they've been introduced to onboard this new functional programming machinery, if you like, into the platform. So let's dig in now and take a look at the different pieces of Java 8 which make functional programming possible. By the way, as we go through these, they might sound intimidating, but don't worry, we'll go through them all in detail in later units. We're just introducing them here so they don't feel so alien to you when we come to talk about them in each different section. So hang in there, all will become clear as we get through the course and look at them all together. First up, we have Lambda Expressions. These allow us to pass behavior as functions, which is a key aspect of functional programming. So what do we mean pass behavior? Well, by behavior we mean a chunk of code that can be executed. So lambdas allow us to pass chunks of code around in a nice, easy and light way. You can think of them as methods without a name for now, which can be assigned to and read from variables and passed to methods. Here's a simple lambda expression to give you an idea. Before Java 8, you could only pass behavior by creating a class which housed the method containing the chunk of code you wanted to pass. But differently, whenever you wanted to pass code around, you had to create a class for it just to be able to do that. And it would be that class which had the method, which in turn had the chunk of code you actually wanted to pass. So with Java 8, we don't have to do that anymore thanks to lambda expressions. As you can see, they're nice and lightweight, they're not heavy on the hands, and we don't need to type a lot. Compare that with the old school way of doing things in the pre-Java 8 world. We'd have to do something like this. Awful stuff. You can see here that we've got to write the enclosing class we just spoke about. We've got to code the clunky method signature too, plus we have an interface, since when it's passed to whatever needs to receive it, the calling code needs to have a way of accessing it, and that's through interfaces, of course. So you can see the pre-Java 8 way is clunky, verbose, and it just feels unnecessary really. It's not just extra typing you have to do though. You have the extra files in your project too, one for the class and possibly one for the interface if you provide it yourself. And you also have the mental baggage now of having to deal with two new types. Well, the good news is that with lambda expressions introduced in Java 8, all this is redundant. You just write and pass a lambda and you're done. Lambda expressions remove the need to create this boilerplate code around the method and allow us to cleanly and concisely pass just the code. Next, we have functional interfaces, which provide a range of so-called target types for lambda expressions. It's great that we can now pass functions around in Java 8 as lambda expressions, but we still need to keep things type safe when storing the lambda expression in variables or passing or returning them from methods. Don't forget, everything always needs a type whenever you do these things, and Java 8 doesn't change this. Java is still very much a strongly typed language, so there needs to be some kind of mechanism of keeping things type safe, and functional interfaces do this for us. To give you a sneak peek, but without going into massive detail here, this is a functional interface in action. Here you can see we're assigning a lambda expression, which doubles numbers, to a so-called functional interface defined in Java 8, the int function. A function, you'll recall, takes an input and returns an output, and in this case it takes an int and returns an int. And because it's pretty common, Java 8 gives us a predefined functional interface for this, which is this int function you see. You can also write your own functional interfaces too, so no need to worry, you'll always have a target type for your lambdas. Getting deeper into programmer productivity, there's now a brand new stream-based API which lets us apply functional programming to collections and chain operations together. For example, filtering a list of objects, then applying a mapping to access a getter on the filtered objects, and finally converting them back into a set. So the result would be a filtered set of the mapped type. Here's a snippet of code which does just that, nice and concise and declarative in nature. So with pipelines and streams, we spend less time saying how we do things and concentrate simply on what we want doing using this declarative style. They're easier to use than explain though, and extremely powerful. So those are the main features in Java 8, but in addition to those, it was necessary to add some other features and concepts too, to be able to make it all work nicely together. In other words, not break existing legacy code, whilst enhancing it to offer the new functional way of doing things. So now we have what I call the other features of Java 8. These are like the glue which binds it all together. In order to program them functionally, particularly with the chaining of stream-based operations we just mentioned, we don't want to have to start worrying about checking for nulls in there. Optionals provide a neat and tidy way of dealing with this. There's an optionals API which is based around providing a type-level way of preventing the dreaded null pointer exception, which fits naturally in a functional context. In fact, there's a whole API written around this optional concept, which means you can not only deal with stream programming in a functional way, but also do some nice functional things with conditionals too, amongst other things. Moving on, we have default methods. These allow us to define implementation code inside an interface. Now this sounds a bit contradictory, after all, we're used to interfaces only having public abstract methods and no implementation, but it's not a mistake, it really does exist. And it's actually an elegant way of being able to evolve an interface, that is, add a feature to it, without breaking existing implementations. This is something that was required to facilitate Java 8 stream-based programming across all collection classes. We also have static methods in interfaces too, which again provide implementation but are not specific to an instance of an interface. So it's a good place to put utility methods, for example, which might belong there. Finally, at least in terms of language significant features, we have method references. These allow you to provide a pointer to a method by just supplying its name. This allows us to reuse existing methods we have in functional contexts by treating them like Lambda expressions and using them in the same places. So for example, we can pass existing methods around using these and plug them into our collection processing pipelines. So, that was a quick summary of the most important features. In the next units we'll look at each in detail to see how it plays a part in the Java 8 landscape. It's a lot to take in, and don't expect you'll understand even a fraction of it from that short overview. We'll be digging into detail in the later videos, but this was just to give you a taste of what's to come.